Good evening, ladies and gentlemen. Hope you're having a fantastic week. And if you're Australian or in Australia, hope you're all geared up for a good day tomorrow. For those who are abroad, tomorrow is Australia Day because we needed another excuse for a public holiday, I suppose. So I'm going to be kicking back in the pool with some friends, with some bevies, with Triple J's Hottest 100 playing. And genuinely, if you're in Brisbane and I've met you before, and I know that you're not a total creep, hit me up. I'd love to have you around. As long as we've met before, I'm not going to go inviting randoms to my place and giving my address to just anyone. But yeah, if you've got nothing to do tomorrow, and I know you, give me a shout. Come over and have a swim, meet some people, eat some snags, and have a few beers. There was an ad, was there? Well, the YouTubers won't have to deal with that. I've got some announcements to make. I should probably do announcements. Chromium. If you're not aware, I will be speaking at CrikeyCon in like a month's time, which means that I need to actually write my talk. I'll be presenting on the bus that couldn't slow down. Yeah, here we go. The bus that couldn't slow down. Someone went and photoshopped Hacking for Dummies in. Got a feeling that was either Bull or Duke. So thanks Bull or Duke. So CrikeyCon is on in Brisbane, February 25. So 29 days. That's really scary. I should say this is my homepage, so I've got like a countdown for how many sleeps I've got to build my talk with. But if you're in Brisbane, or even if you're not in Brisbane, but you feel like checking out sunny Brisbane, you should come along. It's going to be a good conference. A whole bunch of really good speakers, a whole bunch of really cool parties. We've always got like a pre-party the night before. We've got an after party, kind of the night of the conference. It's a one-day conference in Brisbane. You should definitely consider coming along. Second thing I've got to share tonight is we can back around that job, disown it, and exit. I'm leaving Brisbane. If you know me as the jerk with the stupid hair who lives in Brisbane, shortly I'm going to be the jerk with the stupid hair who lives in Melbourne. So if you're in Brisbane, then make sure you come and grab me at the pub sometime, or at Sec Talks next month, or at CrikeyCon. Give me a big cuddle, because I'm going to miss all your beautiful faces a lot. And if you live in Melbourne, then get ready to deal with my stupid face a lot more often. Get ready to show me where all the good spots are in town. Get ready to show me around and basically be my tour guide till I get the hang of the place. I've got a new job, which I'll share some details of closer to that date. But I'm looking forward to it. Should be really good. What are we missing? Will I wear a tutu while giving the speech? No. Short answer, no. Long answer, no. No, I won't be wearing a tutu. Yeah, Men's has got me covered. Thanks, Men's. I'm looking forward to catching up with you again at some pubs. Often. 30% of the conferences at parties, exactly. And CrikeyCon does a pretty dang good job of the parties as well. In Slobber or Love? I don't even know. Null, what's in Slobber or Love? Have I missed something? I probably said something silly. So that's my news. I'll be speaking at CrikeyCon, and then the week after CrikeyCon, I'll be getting out of Brisbane. I'll be back pretty often. I've got a bunch of friends, a bunch of family up in Brisbane, so I will be visiting quite often. So if you're in Brisbane, don't despair. I will be back for visits, but for the most part, I will be residing in Melbourne. Which part of Melbourne? I don't know yet, no. I haven't sorted out exactly where. I'll be working in the CBD, so I'll be living somewhere close to the CBD of Melbourne. Man's got me covered, right? Gotcha. Cool, well, we may as well get on with it tonight. I've got a Boost bar as opposed to a Mars bar chilling in the fridge, so I'm looking forward to that. I don't really have much of a plan for tonight, but tonight was Menstrual's idea. He reached out to me and said, hey, could you consider doing a stream on hash padding attacks? And I went, yeah, sure. And that's about all of I do have a bit of an idea of how I want to approach it. But there's no challenge. We're going to make our own challenge and solve our own challenge tonight. And along the way, I'll speak as to what the phenomena of hash padding is and how it works, how it can be exploited. But really, I've got no concrete plan, so we're just going to make it up as we go. tonight is good, you're welcome. If tonight sucks, blame menstrual. So where should I start? I'm probably going to bounce back and forth between this microphone stand sucks. Get used to this, I'll be doing it all night. I've got the feel. There we go. That'll do. I'll be bouncing back and forward between explaining what hash padding attacks are, implementing a challenge, solving a challenge. There'll be two options towards the end of the night. Either we can do our best to solve it based on first principles and an actual understanding of the attack. It's not my strong suite. I know just barely enough crypto to solve some CTF challenges. But hash padding attack, as the name would suggest, it's a crypto attack on improper uses of hashing algorithms upon message authentication type schemes. So we're bouncing back and forth between how does hashing work, how does hash padding work, building a challenge, solving a challenge. Towards the end, we'll either solve it ourselves or we'll just be script kiddies and grab someone else's pre-canned script that solves them for you. They're a pretty relatively straightforward attack as far as crypto goes. Well, if I can understand it, it's got to be pretty damn straightforward. So let's see how we go, I guess. If there's any questions throughout the night, by the way, yell out, use my name in chat. That way my little Ursi will light up and I'll know that people are needing me to explain myself better, because I've probably failed to explain something properly. SecureWorks got me. No, they didn't. It wasn't SecureWorks. CCPPTT, do I know you? This mic stand I got to fix. Do I know you, CCPPTT? Just because, interesting you'd say SecureWorks. I feel like that did not change the mic stand at all. Oh well. Let's start. Hey, Twitch hash padding. So we're going to create two things. We're going to create challenge.py and exploit.py. So we're going to build our own attack. We're going to build our own challenge in Python, and we're going to build our own exploit in Python. We could make one big super Python file that actually has the challenge and then interfaces with the challenge through function calls. I considered doing that, but then I thought that might be a bit cheap. It might not be clear that there is a clear boundary between the exploiter and the exploitee of hash padding attacks. So I thought by having two Python files, we could maintain those two separate identities with a clear boundary between them. So let's build a challenge. I've barely got an idea of what this challenge is going to look like. Let's write it in Python 3. Do I have Python 3 in this Docker container? Yes, I do. Dang, it means I've got to write Python 3. All right. For the most part, for the next little while, I might go a bit quiet. I might pipe up as things come to mind, but I've really got to kind of plan out and think about how this challenge is going to work, because I don't have a design in mind. I've just got to put it together. How's it going to work? So give the user a well, first we've got to have a secret. So we have to have a secret. So we could do secret equals ASDF HJKL for now. Let's do that for now. We will revisit this secret later. We'll probably generate them randomly upon each connection. Give the user a useless token with signature. This is going to be made more clear later on. I kind of want some code that we can look at to explain in which cases hash padding attacks are possible. So this won't make much sense for now, but it's required stuff. I probably should have built this off stream, but that sounds like effort. So we're going to, how are we going to do this? I really should have done this earlier. Not a good start. Python parse URL. I think we're going to make them URLs. Parse URLs into components. Now we just want to parse a query string, not a URL. There we go, parse a query string, perfect. Okay, so we've got URL parse.parseQS. Then we've got URL lib.url encode to convert dictionaries into query strings. Does URL lib have a URL decode? Let's go Python 3 URL lib. Right, okay, URL parse looks like Python 2, URL lib looks like Python 3. Okay, cool. So we need URL lib. Maybe URL lib.parse. Python 3, import URL lib. Do we get URL lib.parse? Do we need to import URL lib.parse? Yes. What's the function? ParseQS. Yeah, we get that. What was the other function? URL lib.url encode to convert a dictionary into a query string. Maybe it's not in Python 3. URL lib.url encode. URL encode. URL lib.parse.url encode. Yeah, cool. Okay, cool. So I think we're going to need to pull in import URL lib.parse, because then we get encode, and we can give it a dictionary with foo bar URL lib.parse.url encode. There we go. Oops, got to quote the foo. Fizz is buzz. Okay, cool. So this is going to take a Python dictionary and return a URL query string. That's exactly what I was looking for. So we'll go token equals. How are we going to do this? Dictionary. Let's give the token. This is going to make a lot more sense shortly. An expiration. How do we get the Python 3 time now epoch? Oops, nope. Python 3 time. How do I get now? Just time.now or what? No, I don't need time.local time. Python 3 get current time. I should know how to do this. Datetime.datetime.now. Okay. So if we go import datetime, datetime.datetime.now. How do we turn that into .time? Nope. How do I turn that into just a epoch? That's looking good. Now how do we can we just cast that to an int to round it down? That'll do. So let's go and pull in time. Import time. So the expiration date is going to be the integer of time.time plus 1 hour. So 60 seconds times 60 minutes. So token expires 1 hour from now. So as well as the expiration, we're going to have, we're going to have role is, we're going to make it a guest. Make it a guest token. Yes, the role is guest. Now I'm just going to print URL lib.parse. How did we actually generate that URL in code? Here we go. Let's get this. Let's go and encode the token. Which hash padding. Oops, need to quote the keys in the dictionary. There we go. So, oh, that's interesting. Dictionaries, I guess dictionaries don't actually care about the order, because sometimes we're getting role equals guest and expiration equals blah. Sometimes we get expiration equals blah and role equals guest. For a reason that will become apparent later, I want it to always look like this. So I think we need to use an ordered dictionary. Python 3 ordered dictionary. Alright, so we've got collections.ordered dict. D equals ordered dict. Let's try this. Let's go import collections. Token equals collections dot. How was it? Ordered dict. Now, how do we append to an ordered dictionary? It supports the usual dict methods. Okay. Python 3 add to dictionary. Okay, yep, that makes sense. So token is an ordered dictionary. So let's go token expiration equals that. Let's fix this up here. And token role equals guest. Let's try that again. There we go. So now you can see here that the dictionary always stays in the same order, which is going to help later on. Cool. So instead of printing the URL encoded token, we'll go token query string equals that. So now we've got token QS, which is every second. Let's go ahead and print it again. Your token is token QS. Alright, so now if you run this, then you'll get your token is expiration equals blah and role equals guest. And of course this expiration is going to change every second as the clock ticks over. So every time you run it, you're going to get a token. Now, the whole idea of this challenge is going to be that when someone connects to the challenge, they get given a token that is a guest token, where the role equals guest and it expires 1 hour from now. So that's fine. Then what we're going to do is we're going to ask the user to give us a token that they want to use to access the service. Right? So let's ask for a token. I think we can do, is it raw input doot new line that space, just input in Python 3. Yep. So user token query string equals input, please provide a token, right? So when you run this challenge, it's going to give you a token, then it's going to say, please provide a token, and we can do things like just go and paste in the same token, and that's fine. And it's going to be put into user token QS. And then what we'll do is we'll URL query string decode. Actually, let's put some comments here. Ask the user for a token. Decode the user's token. So now, how do we, okay, so parse QS, we're going to do this on it. So the user token is going to be urllib.parse.parseQS over the user token QS. QS meaning query string. Decode it into a dict. And now we're just going to temporarily print the user's decoded token. So let's go ahead and print I got format, and we'll go and print the user's decoded token back at them, right? So you run the challenge, it gives you a token, says please provide a token. You go and give it the same token back, and it says I got, the role is guest, and the expiration is expiration. Looking good. So now that the challenge, the service can actually ask it can give the user a guest token, and then it can ask for a token back. And when it gets a token, it will then print out what it got. So now we can, the other thing is, because we're able to provide a token, we could just do, foo equals bar and fizz equals buzz. And it'd say, I got blah, 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 which is all well and good. Actually, really quickly, I need to check that this urllib parse isn't going to break on special characters. I'm just going to do, just bear with me one sec. This is just a test to make sure things aren't going to break later. Foo equals bar and fizz equals buzz. Yep, that's all good. What if we duplicate keys? I'm just curious. Foo equals and foo equals bar 2. Okay, so when you duplicate parameters, it looks like it creates a list. Okay, should probably keep that in mind. What if we go and put null bytes and stuff here? Hex 00, hex 00. Let's go and put hex 81, which is a non-ASCII character. And let's go and do buzz 2. So it looks like it can handle null bytes and unprintable characters just fine. That's good. That'll make things okay later on. Now, what are we going to do? We should do some sanity checking. As the service, we should do some sanity checking on the token that got back before we print it. Actually, we'll do it after we print it, because this is just a debugging thing. Sanity check the user's token. Now, this is not supposed to be safe code. I probably wouldn't be flinging query strings around and parsing them and working with them like this. This is just really rough but honest challenge code. And we need to do some sanity checking to at least make a half-honest attempt. What have I missed? Oh, right. Yeah, that's cool. Yeah, no, it wasn't SecureWorks that got me. Time.time, yeah, thank you. Hey, Singularity, how's it going? Good to have you around. Did I release my exploit? No. Hey, on which exploit? Did I talk the other night about how I had some exploits coming up? Because there's nothing been released yet. They're not going to be exploits either. They're I might do an exploit for one of them. I've got some advisories coming up soon. But no, there's 2 in the works. There's 3 in the works. 2 that are pretty shortly going to be announced. One was going to be today, but it got postponed. And there's another one that should be in the next couple of days, perhaps. So stay tuned. Yeah, stay tuned. Hopefully the next one of them should maybe be the next couple of days, unless something goes wrong. The other one might be in a couple of weeks. We'll see how that goes. So now we want to sanity check the user's token to make sure that what we got back at least makes some sense. We want to do things like make sure they didn't go and give multiple values for anything. We want to make sure it has an expiry, and we want to make sure it has a role. So let's do if well, if it doesn't have a role or an expiry, we could just have it chuck errors. Can we do foo in that true, foo2, yeah, cool. So if not, so if not, how are we going to structure this check? How would you do if expiration not in user token or role not in user token? Let's go and pull in sys just to give us a really, actually, no, let's def main. If name equals main sys dot exit main import sys. Okay, so if we end up caught by this check here because the user failed to give expiration or failed to give role, we'll print out an error. Let's go and prefix it with a bang. And let's go and return -1. Go and run the challenge. Whoops. Provide a token. ZZ equals AA. Yep. Invalid token needs expiration and role, as opposed to expiration equals foo and role equals bar. Yep, that looks good. Python 3. How do we check? Actually, no, fuck it. We'll just cast it to an int later. We don't need to check the type of the expiration or the type of the role. How do we make sure someone didn't give multiple values for the same thing? Just like this here. It's not going to help us there. How are we going to check to make sure people didn't give multiple things? Python 3 check type. Python 3 check type. Okay, so what we can do is if not array check. Yeah, that's what I'm thinking. Null, where should you keep an ear out? On Twitter. I'll be punching them out. What you can do actually is if you, I don't know if you put a watch on this repo. When they get published, they will go to my advisories repo on GitHub. So you may wish to watch this repo. You may be able to get emails whenever there's pushes to it, which is a way to get, fresh off the press advisories from me. Otherwise, I'll be tweeting. Yeah, Menz, I think I'm going to do this here. we've got some duplication. I'm going to dedupe this for K in expiration and roll. If K not in user token, it's a bit more succinct. So we're going to check to make sure that expiration and roll are both there, and then we're going to check to make sure that they're both not lists. So let's go and yank 5 down. I'm sure there's a whole bunch of actual developers who are cringing at the way in which I write stuff, but that's okay. For K, for the key in the expiration and the roll, if type user token K, because we know it exists now, is not string. Is that what I do? str is not str. Invalid token. HPP detected. HPP is HTTP parameter pollution, which is when you give multiple values for a single key, or you use the same key twice. Does that work? Run the challenge. Let's go and do that, and then do and roll equals admin. There we go. Invalid token HPP detected. That's what I wanted. Whereas if we just give the token, aha, it still detects because it is a list. It's always a list. So what we can do is we can just check the length. For K in that, if the length of user token K is not equal to 1, that's when there's HPP, because the dictionary never contains strings. It always contains lists. Just sometimes usually there's a single string inside each one. This should work. Let's go and give the token. Yep, there was no error. Let's go and give the token and then roll equals admin. And there we go. HPP detected. Fantastic. So we've got the sanity checking done. We're checking to make sure that the required fields are in there, the expiration and the roll, as well as the fact that the user's not supplying the same key twice. Fantastic. We're only checking the key is not duplicated for the important things. If they go and give multiple extra fields, we don't really care right now. This is not terribly robust code, but it'll do. So once we've sanity checked the user's token, what will we do? We will I'm just going to put a big honking to do here. Check that the expiration. Actually, we can probably do the expiration check. If user token expiration is less than the current time. How do we get time? Was it just time.time? Yeah, there we go, time.time. Oops. If the user token expiration is less than time.time, print a nasty error. Print token is expired. Now what we need to actually do is we need to cast this to an int. Actually, now that we've checked the user's token for sanity, we know that there's both fields are there, that there's no HPP. Let's actually go and extract. Let's go and get the user expiration. We're going to cast the user token expiration to an int. And the user roll equals, we're just going to go and grab the user's roll as a string. Righto. So now that we've actually casted this to an integer, we can do if user expiration is less than time.time, print the token's expired. So now if we go and give the token again, oops, it's a list, not a string. Right, what we can do is, actually, you know what, we don't really need to check for HPP. Let's not check for HPP. Let's just always go. No, let's leave the HPP check there. So we need to actually pull out the 0th entry in these lists. Cool. Try again. Let's go and give a token. Everything looks good. Well, let's actually go and print. Token looks good. Do that again. Paste the token. Token looks good. Whereas if we go and do roll equals guessed and expiration equals 1337, which is a time way in the past, we get token is expired. Fantastic. So now we've got expiration checks being done as well. Perfect. So we want to check the user's the expiration, and then what we want to do is now that we want to get to the interesting stuff, we want to see if the user is an administrator instead of a guest. So to do the check to see if the user is an admin, because we know that our software kind of sucks, and sometimes we use the word admin, sometimes we use the word administrator, sometimes we do it all uppercase, sometimes there's a capital A. We're just going to check to see if the lowercase string admin appears anywhere inside the user's role as a string. How do we go Python 3 to lower? String.lower. Do we just do Python 3 asdf.lower? Awesome. Cool, we do. Let's go and... No, let's not change the user's role case there. Let's do if... user role.lower. Let's do if... Actually, let's do if admin in user role.lower. Print you are an administrator. Hooray! Else print you are a lowly non-administrator. That doesn't look right. Administrator must have been right. Boo. No, we don't need that anymore. Oops, that's not the challenge. Let's go and give this token back. You are a lowly non-administrator. Boo. Let's run it again. Let's change the role to admin. You are an administrator. Hooray. Okay, so this is where we want to get to at the end of the night, where we are an administrator. Now, if we didn't actually go and add some sort of way that the server can verify that the token is actually a genuine token, we'd be done. And this would be a really terrible application because it would have essentially no authentication. It would not actually check to authenticate whether the token that you're giving is a genuine token or not. You could just go and change the role to admin, and that would be terrible software. I'm sure it's out there in the world, but it would be terrible. So the administrator, the developer kind of at this point would sit down and go, oh, okay, I need to check to see if the token is a token that I actually gave out. And some people think, all right, what I'll do is when I give out a token, so all the way up here, print your token is that. We're going to give the user a signature of that token. And the developer kind of sits there and goes, okay, what if I just do like a SHA-1 hash of the token QS and hope that the user doesn't realize that whenever I give them a token, it's just a hash. So let's do that. Let's make the signature of the token just the SHA-1 hash of the token. So Python 3 SHA-1 hashlib, that's right. Import hashlib. M equals blah. Update digest. Okay, so we're going to do hashlib.sha1. Python's going to be a jerk with binary strings and Unicode and stuff, isn't it? I'm still getting the hang of Unicode in Python 3. You know what? I'm going to be a real jerk because I don't want to end up deep in the depths of hashing and wondering why stuff's not working and finding out it's because the strings were Unicode, not ASCII. I want to deal with ASCII bytes and I'm not confident in my ability to force Python 3 to do ASCII everywhere. I'm still getting the hang of Python 3. So I'm going to go Python 2, cross my fingers, and watch it break. Yep, no module named parse. So how do we do the Python 2 stuff of URL lib? Sorry, I should have thought of this before we started, but now we've got to actually port this back from Python 3 to Python 2. Otherwise, I just know we're going to have Unicode problems in our hashing. Alright, so we're going to have to use URL parse for the parsing the query strings. URL parse. Let's go URL parse. No, that's not where I wanted to change things. Here, when we decode, we want to do URL parse dot parse QS. Yep. Cool. And hopefully it still has the same interface and has the same return values. We also need to fix this here. I'm going to use URL lib.url encode. Yep, URL lib.url encode. So we're going to need to pull in URL lib. Let's see what else is broken. I think we've got to change that input to raw input. Okay, this is looking good. If we do that and role equals admin, we have the HPP check. If we do foo equals bar, then we get needs exploration and role. All right. And finally, if we do, oops, role equals admin, we get you're an administrator. Okay, cool, we're back on track. So now we've turned our Python 3 script into a Python 2 script because we're terrible and we should feel terrible. Alright, so now we're going to build a signature using hashlib. Now that we know that we're dealing with ASCII strings, not Unicode strings. That's what she said. Alternate. Okay, we're deep in the alternate facts now, are we? What have I missed? Yes, singular, and also temporary workaround never is. The temporary workaround gets into production and it never gets fixed as well. Yep, indeed. Here we go. Protoduction. I haven't heard that one before. I was going to say, here we go with all the old test versus prod jokes, but I hadn't heard protoduction. That's good. Nice. Hey, J-Thorpe, good to have you around. You haven't missed anything at all, just me actually building the challenge for the night. We haven't actually covered anything important. I'm literally building the challenge. We're gonna solve our own challenge because we're good like that. We can only solve the things that we build. Yeah, no, go. Please enjoy yourself while I continue to fumble my way through feeling terrible about life decisions and using Python 2. So I need to build a signature. So we're going to do signature equals, we use hashlib. Here we go. It's going to be a SHA-1 of the token query string. And then we're going to go print. Oh, the print with brackets works in Python 2? Really? Is that new? I thought you had to like import future to be able to do stuff like that. Python 2 print brackets. Is that actually supported? I must be mistaken. Yeah, cool. I think it's still bad form to use brackets in Python 2. I'm printing a tuple. Oh, really? That's... Thank you, old mate. So if we were to do like print foo, you're printing a tuple. If you go Python 3 and you go print foo, you can't print a tuple. Okay. Maybe it's just you can't have maybe you just can't have white space between the function name and the function argument brackets. All right, old mate, that makes sense. I feel bad about that. I'm going to get rid of all those brackets. So I don't think it's kosher in Python 2 to have brackets. Makes me feel bad at least, which is good enough reason to get rid of them, right? By the way, old mate, welcome. Welcome, welcome, welcome. Good to have you around. I want to create a channel. I have to use only licensed software to stream. I'm not sure. Not happening, Noel. Not happening. Good question, Carla. Welcome, by the way. If you read the Twitch terms of community and whatnot, I'm pretty sure they say that you can't use, for example, pirated games. So I'm guessing that extends to software. If you're going to use software, it should probably be licensed if you're going to stream. All my software, by the way, is licensed. If anyone's curious, I'm a bit of a stickler about software licensing. So all my stuff is legit. My Burp's legit. My IDA's legit. My Windows is legit. My Linux, I've got a Linux license, so I'm good to go there. But yeah, Cole, it's up to your understanding of the terms of service for Twitch as to whether you can stream pirated software. Yes, I am at Wolf indeed. Welcome, welcome, welcome. I should use... I know, there's so much Vimage that I need to learn still. You type DS bracket. Yeah, thanks, old mate. I'm gonna bookmark that in my personal browser. I will check that out. If anyone else has got Vim tips, I'm super keen until we get to like the 7th one of the night. Then I'm going to tell you to shut up and let me do my work. Thank you, old mate. All right, so we're back to signatures now. We're going to go signature equals blah, blah, blah. I'm going to go print your signature is signature. So now we run the challenge and we get your token is this and your signature is, I forgot a digest, didn't I? Yeah, .hex digest. Yep, there we go. Okay, so your token is this, and your signature is that. Cool. So now we need to ask people for their token and signature. So yank that. Please provide a signature. Signature equals raw input. So now when we run it, we get to provide a token. I'm gonna go that. Where's my prompt for a signature? There it is. Please provide a signature. We're going to give the signature as well. So now, before we get to this bit here, we need to actually check the signature to make sure it actually matches the SHA-1 hash, to make sure that what they gave as a... And by the way, I know this is insecure. We're working towards where we're going with it. We need to check to make sure that the user's query string that they gave has a SHA-1 hash that actually matches the signature that they gave. This is not at all authenticated, but we're working towards an authenticated solution. Do I have an encrypted boot? Volko, that sounds like a very personal question. Do you ask everyone about the state of their boot? No, I don't have an encrypted boot. I would like to. I would like to learn how to do like a full trust chain from... I'd be interested in seeing whether something like Secure Boot or other, crazy EFI technologies can be used to sign your own bootloader. If you could basically generate keys, poke them into your BIOS or into your EFI firmware, and then have that check the chain so that I could have an encrypted boot that is also signed and boot clean the whole way through, with a trust point being my own PKI. I'd be super curious to look into how that would work. But to answer your question, no, my /boot is plain text. I would love to have it encrypted, but the main reason you really want to encrypt your /boot is to prevent, I'm guessing, evil maid attacks. Like my disk is full disk encrypted, my slash and my /home is full disk encrypted. And I guess the reason for encrypting your /boot, I've got no sensitive data on my /boot, but I would hate for someone to monkey with it if they got a hold of my machine. I'm not sure if encrypting /boot will protect you from that, because otherwise they'll just go and change it out for their own encrypted /boot that's been backdoored, and then your boot chain's compromised. I'm guessing what would be interesting is to actually make sure that something like Secure Boot can guarantee your own personal boot chain, so that someone can't just go and take some signed stuff that was signed by whoever else and replace your boot chain with it. Your entire boot chain is personally signed. I think that would be really interesting to look into. Check boot, hey? How does check boot work? I haven't heard of check boot. Exactly. I'm thinking, correct me if I'm wrong, Volko, but is that not the reason why you want to encrypt /boot? It's to ensure the integrity of it. I don't give two shits about the confidentiality of /boot. I've got no sensitive data in /boot, but I'm worried about the integrity to make sure no one mucks with it. Seems to me like something like check boot or secure boot would be the way to achieve that, not encryption. But I could be wrong there. I reckon this is vulnerable. I don't reckon check boot would help, because if someone knows you're using check boot, surely they can compromise your boot chain in such a way that when the check boot that they know you use kicks in, the booted kernel will basically be rootkitted and give up false information to check boot, ensuring that check boot doesn't alert you. It seems like to me this is moving the problem around the plate a bit. And all it would require is that the compromise done to your boot chain be smart enough to actually lie to check boot once check boot gets invoked. Because if you've got a compromised boot chain which boots a compromised kernel, all bets are off when you get to your own slash. You know, any startup scripts you've got there will be running within a compromised kernel, so you're stuffed no matter what. Seems to me like this just moves the problem around the plate. Yeah, exactly. You signal your store. Thanks, Singularity. Yeah, they could Volko, or they, you know, if they just know what to hook, then they could basically, as the kernel, detect that check boot is lit up at all, and just do the needful to make sure that it's satisfied no matter what it's looking for. I'm sure you could write an implant for the kernel that basically is check boot aware, spots it running, and goes, all right, let's activate defenses and make sure that check boot, even without caching the pre-compromise. I mean, yeah, you're right. You could generate the right hashes from the pre-infected /boot and then cough them up later on, or you could just do the needful to go, hey, check boot. You can just piss right off. Helping indeed. Don't have boot on your system and keep it all on a USB key that you take with you. Good idea, Atwolf. That would probably also do the trick. It would be a lot easier if the USB key stays in your pocket all the time to ensure the integrity of its contents. Yeah, good idea. It's probably something to be looked into. Alright, let's get back to this nonsense, hey? So we're going to ask the user for a token and a signature. When we sanity check the user, we're going to sanity check the user's token. And then we're going to check the signature. I'm going to call this the user signature. So now we do if where was my hashing? This here. If the SHA-1 of the user token QS, you know, let's do this signature check. Let's do the signature check after the sanity checks, because the sanity checks might be, I mean, in production you'd probably put this before the sanity checks and bail out early if the signature's bad. But if we keep it in there, then it may help with some debugging during the exploit, which is cheating, but hey, it's my challenge. I'm going to do what I want. So if the hash lib SHA-1 of the user token query string, user meaning the one that the user gave us instead of the one up here, which is the one that we generated for temporary use. If the hash.hex digest is not equal to the user signature, then we print bad signature and return -1. See how that goes. So we can give the token, blah, the signature, blah, and everything looks good. You're a lowly non-administrator. Now if we were to go and change the role from guest to admin and go, oh, signature, I don't know, give the same thing, we would get bad signature. I'm going to get rid of this debug here. We don't need that anymore. Now that we know that our decoding is working properly, get rid of that. And the attacker would go, oh, okay, damn, that's a bad signature. Then the attacker might go, well, this might just be a SHA-1 of the token. What if I just go and muck with the token and then generate my own SHA-1 hash of what I mucked with and give that as the signature? And the attacker might go, I got this. And they're going to go, the token is, we're going to change it from guest to admin. And for the signature, the attacker is going to go echo-n, give their modified token to SHA-1 sum. They're going to grab this hash here, paste it in, and they're going to go, I'm an administrator, hooray! And the attacker has won again. So the developer is going to go, all right, so an attacker might do this. An attacker might forge a signature using the hacker tool SHA-1 sum, and it means that I'm back to square one. The user can go and create a token that has admin in it when I didn't give that token out. And the developer might go, okay, how can I make this signature impossible to generate? Well, you might notice here that I thought ahead and actually I've got a secret. What they might do is go, what if when I generate the signature, it's the SHA-1 hash of my secret value plus the token query string, right? And then later on, when I do the check again, I will prepend what the user gave with the secret and then see if the hash matches when we get down the bottom. So at this point, the developer's probably gone, well, I've got code duplication. I'm going to actually define a function. Generate signature over some data. Going to return this here. I'm going to take a secret and some data. I'm going to append secret to data. Right? So we're going to. This signature is based on the scheme of prepending the data with a secret. So the signature is going to be generate signature over the secret and the token QS, right? And wherever down here where we did the check, we're going to comment that out. We're going to do if generate signature over the secret and the user token QS is not equal to the user signature that the user provided, then print bad signature. This S here needs to be secret. Right. So now what's happening is the developer at the time of generating signatures is prepending it with this secret value ASDFHJKL, right? So the user can go, okay, so here's my token. The signature is this here. Everything's great. The user might try to be cheeky and go, the role is admin. Oh, signature. Crap. I'll just give the same signature as before. Whatever, no big deal. Bad signature. Then the user might go, well, what if this is just a SHA-1 hash? The user might go, okay, here's my token. I'm going to swap out the role for admin. Signature. I'm going to use the hacker tool SHA-1 sum again. I'm going to put my own token in the middle here. I'm going to copy that SHA-1 sum. And it's still a bad signature because the signature scheme is now to prepend the secret token ASDFHJKL onto the beginning of the my brain just broke, onto the beginning of the string being hashed, right? So now the user, if they were to try to beat the system, would need to go, my token, I'm going to swap guest out for admin. And the signature, again, they're going to use the secret hack tool, SHA-1 sum. They're going to need to prepend the string with ASDFHJKL and then their token, right? And this prepending of ASDFHJKL only happens when you're building the signature using SHA-1 sum. You're going to copy the hash, paste it in, and they're an administrator. So the user has won again. But to win, the user had to know the secret string at the beginning of the string being signed, right? They had to know the secret string that goes at the beginning of the string being hashed. So here was their input from before. Your token is, no, please, yeah. So here's the token they gave with role equals admin. What they did is they put it inside some quotes here. They prepended the secret and then punched all of that into SHA-1 sum, punched out a signature, and they're in. So to do this, they had to know what this secret was. And the developer is going to go, well, I'm going to pick a better secret than ASDFHJKL. I'm going to pick 32 random alphanum characters, and that's what they're going to go with. And at this stage, the developer's feeling pretty good about life. They're feeling like, well, I'm using a hashing algorithm. I've got a secret that if the user doesn't know the secret, they're not going to be able to build their own signature using the SHA-1 sum, the SHA-1 algorithm. They're going to need the secret token to put at the beginning of their token and to then hash to then be able to change their role from guest to admin. So the developer thinks that at this stage, you're stuck with giving the exact same dumb old token back with one of the developer's magic signatures. And they think that this is pretty good because it means that if I ever get a token and then a signature where that signature matches my secret string and then the token that the user gave appended, I'm going to use this as a scheme to make sure that the tokens that I get with the role equals guest or the role equals admin or whatever's in it actually came from my software and my software actually generated it. And the developer's feeling pretty good. And obviously this is still not a secure scheme, otherwise we wouldn't have anything to do for the rest of the night, right? So I'm going to take a quick 5-minute break. You should too. Now's the chance to, I'm going to go grab a beer because it's almost Australia Day, so it's almost time to start getting on the terps. I'm going to grab a beer. We'll reconvene in 5 minutes. If you need to use the bathroom, if you need to grab some water, grab a bevy, now's the time. And we'll be back shortly to think about how we can defeat this using hint hint hash padding attacks. Back in 1 minute. No, 5 minutes. Back in 5 minutes.
changes.
Life. Life.
Alrighty, let's get back into this. Hey, by the way, everyone, cheers. Hope you enjoy your day off tomorrow if you're in Australia. If you're not in Australia, a day off is what you're missing out on. Did I see the guy whose vape blew up in his face? Yeah, that I've seen a couple. They crop up quite often. I think I know the one you're talking about, and that was a very sad one. I didn't find out what the root cause was. Often when people's vapes blow up, or often when people say, my vape blew up in my pocket, really what people are generally doing is they're putting their batteries just in their pocket next to their keys and coins and stuff. And these batteries, the batteries that go in vapes are deceptively powerful. They're actually generally what go in laptop batteries. In a laptop battery, there's often just these end to end to end to end, which is why sometimes some laptop batteries have like a little round bump under the bottom, just because it's just these side by side by side. So if a couple of them, or more than a couple, if a handful of those are enough to power a laptop, there's quite a bit of juice in them when they're fully charged, or even when they're not fully charged. And what can happen is if metal gets around the whole thing, then bad stuff happens. Or if metal even just kind of gets in the top there, between the insulating ring and the positive terminal, then how a battery works is this negative terminal down the bottom. It's not like two ends of a battery. It's more like this negative bit is actually the casing around the entire tube. So that there is the negative terminal, and all along the sides is the negative terminal. So if you ever get like a cut or a split on the plastic up the top here, or if metal makes its way in and then under the little insulating ring around the top, it can touch metal to the metal a couple of millimeters away, and you get a hard short. And when these batteries hard short over not a lot of resistance, they enter, I believe they enter thermal runaway. The battery gets hotter. The hotter it gets, the more power it discharges. The more power it discharges, the hotter it gets. The hotter it gets, the more power it discharges. And then they tend to explode, and bad things happen to people's legs that are right next to the pocket that the battery was in. So often when vapes blow up, it's because people aren't respecting and handling their batteries properly, which is terrible, but it is avoidable. So, and then when people's mods blow up, that's because it's often because they've got batteries with cuts and slits in the plastic, and then inside the metal body of the device, the casing is kind of then making a hard short between the positive and negative terminals. Battery enters thermal runaway, and bad stuff happens. So it is terrible. Generally, it's preventable. And if you vape, you should be very respectful of your batteries, because they are dangerous things. You should work on that indeed. Yes, so tonight's stream, when vapes go boom. Damn it, chat, stop distracting me. All right, so we've built a challenge, right? So if you missed it, this is what we're working with. Python script. This Python script is the challenge itself. What it does, there's some kind of boilerplatey kind of stuff, but what it does is it gives the user a guest token with a signature. And when you run the challenge, you get something that looks like this to start with. Which looks like that there. So the challenge will give you a token which looks a lot like a URL query string. We're actually using URL query strings to serialize dictionaries of data. So it's going to give you a token that looks like this with an expiration time and a role of guest, and then it's going to give you a signature. I'm going to go into what that signature means in a second. It then asks you to provide a token. In this case, all I've done is I've just copy pasted this token here and pasted it in there. And it says, please provide a signature. And all I've done is copy this signature there and paste it in there. And then the challenge has accepted the fact that this signature does indeed relate to that token and is a valid signature for that token. It then parses the token and sees that the role is guest and says you're a non-admin. The way to win is to get this message here. You're an administrator. To become an administrator, you have to have a token where the role contains the string admin, and you need to give a signature that is the signature of the token you've given, right? So you need to first of all craft a token that has the role equals admin. That's easy. That is really easy. You literally just copy this here, and then you backspace the guest and put the word admin. Done. the signature is difficult. Well, it's supposed to be difficult, right? Due to the scheme we've cooked up, it is a vulnerable scheme, and we're going to get into the vulnerability shortly. But this is how the scheme works. A signature is created by the generate signature function. So the generate signature function takes two values, a secret and some data. It then appends the data on the end of the secret. So did I say signature? That's a secret and some data. The function then takes the secret, appends the data, and returns the SHA-1, the hexadecimal digest of the SHA-1 hash of that concatenated string, right? So the program, this challenge has a hard-coded secret of ASDF HJKL, and we'll change that in a second. In fact, let's change it right now. Let's just go and echo foobar into SHA-1 sum. There we go. That's going to be our new secret. The secret is going to be the SHA-1 sum of the string foobar. All right, so it's not a very random, good, strong secret. It could be guessed, but for the purposes of demonstration, this looks like a relatively complicated string that should be hard to guess. I've got my moustache is tickling my nose. It's annoying. So the challenge will actually cough up a valid token with the expiration time being 1 hour from now, and the role being guessed, and will then cough up a signature of that token based on this secret here. So what you're more than welcome to do is run the challenge. When it asks for a token, give it this one. When it asks for a signature, give it that one, and you're in, except you're a non-administrator. If you wanted to try and be cheeky and change the role to admin and give the wrong signature, it'll complain that it's a bad signature. To be able to craft a signature, in theory, you need to know the value of this secret so that you can prepend it to the token you're giving with where the role equals admin so that you can generate this signature, which theoretically should be pretty hard. But there's a vulnerability in the way in which the SHA-1 hash algorithm is being used, in this case, using concatenation, which we'll get into. Before we get into that, we should probably edit the exploit. And this will be Python 2, so I can use Pwn tools, import Pwn. Right, so I'm going to just build a really quick exploit that basically runs the challenge, carves out the token, carves out the signature, and then just sends them back and gets the message saying, hey, you're a non-admin. That will at least give us a skeleton off of which we can hang some code to actually exploit this weak signature algorithm. So we're going to go tube equals pwn.process. So yes, we are using Python to exploit a separate Python script, but we're doing that so that we've got clear delineation between the challenge and the exploit, so that they're not the same Python process, and I couldn't possibly be cheating and reading the secret out of memory. And later on, what we might do, if we want to be really cheeky, is we might actually have the challenge generate a random secret every single time you run the challenge script, which will mean that there is no possible way that I could be guessing that secret. So we may get that far later on, we'll see. So we're going to go t.process, and we're going to run challenge.py. Let's just go t.interactive. Curious as to whether Pwn tools can actually run a Python script for us. So that's the challenge. Let's go exploit. Yeah, there we go. Starts local process challenge.py. Switches to interactive mode, and here we go. So we can go. Here's the token. Here's the signature, and there we go. We want to automate that though. So let's go and get the token, or get the guest token. Token equal. Let's go t.recv until. I'm going to receive until. Let's go and swap these out for single quotes. I'm trying to get in the habit of using single quotes except where I need them. I see a lot of other people doing that. It seems like a good idea. What beer am I drinking? Cooper's Green. If you're a foreigner, this is my usual drop. This is my cheap beer. I bought a couple for tomorrow. It's not a fantastic beer, but it's a super sessionable beer. It's a pale ale. It's bottle fermented, or bottle conditioned. So if you looked up to the light, you can actually see little bits of floating yeasties in there. It's just a great staple, relatively cheap. If you're foreign, then you're probably seeing $18 for a 6-pack and going, that's not cheap, but that's just how much Australians pay for their booze. This is my session beer, and I've got a couple in the fridge for tomorrow as well. So tonight's drop is Cooper's Green or Cooper's Pale Ale. So we're going to receive up until your token : space. And then token equals t.recv line. Pwn tools recv line. I think it's keep. Is it keep ends? Keep ends equals false. So I want to read the rest of this line here, but I don't want that trailing new line. Recv line. I'm going to direct v line keep ends equals false. Just going to really quickly hex and code that to make sure I don't get a new line. Yep, there's no 0A on the end there, so we've managed to chuck away that new line. Cool. So we're going to get the guest token. We're going to get the signature that the service coughs up for us. Signature equals... actually, we're going to go t.recv until... And we're going to eat this here and just chuck it away. And we're going to do the recv line again, except this time as the signature is t.recv line. And let's go pwn.log.info got token. Token. Let's do it again. Got signature. Signature. Now if we run the exploit, then yep, it's successfully grabbing the token, successfully grabbing the signature, and now the program is asking us to provide a token. Send the guest token and signature. T.sendLine token T.sendLine signature, and then we won't go T interactive. We'll just go print until EOF. Actually, before we send the token, let's just go t.recv until a new line greater than space to go and eat up until the prompt. Do it again before the signature, and then we'll just print until EOF, which is going to be print t.recv all. If we run that exploit, then something's blocking. What is blocking? Is it one of these two? Yes. Because we don't have that new line in the chamber anymore. Let's just receive until the greater than. That'll do the trick. No, what's going on here? Hang on. Why is it blocking on these recv untils? There should be two in the chamber. Gonna receive the line your signature. Why is that not sitting in the chamber? What is in the chamber? It's probably a buffering problem. Yeah, because we're not printing new line. This is a output buffering problem. What are we going to do about this? Python output buffering. Let's go and unbuffer the output if we can. It's a problem with the challenge. The challenge is holding on to the lines that don't have a new line yet. Shebang user bin env python-u. That sounds legit. Let's just go and hack the challenge to unbuffer the output. Boom. Has that fixed our buffering problem? Yes, except we get something else. Did I just break the challenge? Yep. Shebang user bin env python-u. Doesn't work. There you go. Feels a bit heavy-handed, that one. Is there a cheap way to get Python to unbuffer its output? Oh, what have I missed? The signature and token could be something that's set in your cookie when you log into it. Yes, totally, Menstrual. This is actually how Rails does cookies. Rails signed cookie. So Rails actually goes and bakes the signature right into the cookie. A lot of frameworks do signed cookies. It makes stuff like load balanced things easier. When all your backend servers have the same cookie signing secret, signed cookies means you don't need to actually share session state between your backend servers. It'd be nice if we could actually see an example of a Rails cookie. Come on, you can do it. You got this. Excuse me. So this is an example of a Rails cookie, right? You got the data, then you got dash dash, and then you got the signature. Spoiler, Rails doesn't do simple concatenation with these signing like we are. Spoiler, it does something like HMAC, I'm sure. Otherwise it would be vulnerable to exactly what we're doing tonight. But Rails actually goes, this is what an entire Rails cookie looks like, and it's just got a dash dash to delimit the data and the signature, and it puts them all in one big blob. So eventually, yeah, you could do this in a web app. A lot of frameworks actually do it. I've got hiccups now. Yeah, slow internet won't be a problem in Melbourne. I reckon it was this blog. This blog was probably a bit rusty, I reckon. Thanks, old mate. I guess we could probably just set the environment variable when we launch from the exploit. Do I have unbroken the challenge? Nope. Let's get rid of this -u. Okay, the challenge is working. So what we should be able to do is set the environment to include the string unbuffered equals doot when we do this pwn.process. Pwn process. Just do, I think, env equals a dictionary. So if we weren't being lazy, we'd go and take the current environment, then append to the dictionary, but let's just go and set it to a brand fresh new dictionary. Let's go env equals dictionary with unbuffered, Python unbuffered equals, whoops, is doot. That should unbuffer the output, I'm guessing. Run the exploit. Hey, this looks good now. Yes, so the t.rectv until with the greater than the space, it just worked that time. We get the message, you are a lowly non-administrator, boo. Thank you, old mate, that's probably the cleaner way to do it. Thank you. There you go. Indeed. Yeah, I could do that as well. I could set it, I could chuck it in the environment of the Python's, of the challenge of the exploit.py. Of challenge.py. Yeah, env equals. Easy done. Alrighty. Okay, so now we've got an exploit that actually can interface with the challenge. And at the moment, the exploit simply sends the token and the signature that it got from the challenge straight back at the challenge to become a non-administrator, which is not exciting. Now we can start to get down to brass tacks. Right? To craft a guest token where the string admin is in the role. To craft a signature for the crafted guest token without knowing exactly what the secret is. This bit's easy, right? We can do that. This bit's hard. This bit's really hard because we don't know what the secret is. That's the whole idea of the scheme that we're trying to defeat. Once we've done these, we'll just send the crafted guest token and the crafted signature back at the challenge, and we win. So this is the crux of this evening, and this is where hash padding attacks or hash extension attacks come in. You're killing me, minstrel. Is NBN widespread in Melbourne? Like, is it in many places? So hash padding attack. Is this, if anyone's reading this with me, is this ringing any bells? A length extension attack is a type of attack where an attacker can use the hash of message 1. So where message 1 is going to be something like this here, expiration equals something and role equals something. We get the hash of that, right? Well, we get the hash of the secret prepended to that message. So we know what message 1 is. It's this. We don't know the secret, but we know the hash of the secret plus message 1. This is it right here. We need to know the length of message 1. So to know what the length of message 1 is, because keep in mind message 1 is actually the secret plus the token. So we need to know the length of message 1. Well, we know how long the token is. We can see it right here, right? We don't know how long the secret is, so we do need the ability to know how long the secret is. And I'm thinking we just cheat. I mean, you could brute force it online. The length is super brute forceable. The secret itself is not brute forceable, but you could brute force the length of the secret. Go, maybe it's a secret of length 1, 2, 3, 4, 5, 6, 7, all the way up to 1,000, or however long you think the secret might be, and eventually you'll get the right length. So we can use the hash of message 1 and the length of the secret, basically, and we can calculate hash of message 1. This here means concatenate message 2 for an attacker controlled message 2. This attack can be used to sign a message when a Merkle this is going to embarrass me. That word, Merkle Damguard, I don't know, based hash is misused as a message authentication code, allowing for inclusion of extra information. This attack can be done on hashes with the construction hash algorithm done over secret concatenate message. Like this here looks super familiar, right? If we go back to the challenge, hint, right? You know, hash secret plus message, hash secret plus data. When the message is known and the length of the secret is known, well, we know the message, it's right here. The length of secret, I'm just going to cheat. And how long is a SHA-1 hash? Is it 32 characters or 40 something characters? Len of that. 40 characters long. So the secret is 40 characters long. So we're just going to pretend we know what that is. If we know the message and we know the length of secret, then we can calculate the hash of the original message, which was the secret plus the token, with our own stuff appended on the end. If we can append to the end of this token, we can just put the word admin anywhere inside the role, and it will pass this check here. You can see now why I made some of the decisions that I made while building the challenge. This length extension attack looks like exactly what we need. This length extension attack says that we should be able to calculate the hash of this token plus the string admin, which is going to make role equal, guest admin, which will pass this check here and make us an administrator. As long as we know an example signature and how long the secret that got prepended to message in building that signature is. It can be done on the algorithm SHA-1. Here's a spoiler. Since HMAC doesn't use the construction hash, key, concatenate message, HMAC hashes are not prone to length extension attacks. So, if you were watching me build this and you've kind of got a side job as a developer, and you're thinking that the solution we used was pretty legit, just prepending a secret to the beginning of a message and then hashing the whole thing, in certain circumstances that is vulnerable to a length extension attack or a hash padding attack. And instead of using a hash algorithm, you should use HMAC. You can use things like MD5, I don't know why you would, and you can use hash algorithms like SHA-1 as the mechanics of your HashMac process. HashMac is a very general idea. In fact, is it a wiki link? Yeah, it is. Basically, a HMac will double wrap stuff. You can see that there's a H here and a H here. And due to this double wrapping and the way in which it concatenates a couple of things together, HMac uses the key in very particular places inside the mechanics, but this H here inside HMac, that can be SHA-1, totally. It just means that you need to kind of wrap SHA-1 inside SHA-1 and concatenate things in various places to become resistant to hash padding attacks. And you don't need to do this yourself. Any good library that provides hash functionality, if your library lets you do a SHA-1 hash, I can almost guarantee that your library will let you do HMACs. This here will come for free with your hash library. In fact, Python hashlib, we're using hashlib in this challenge. Does hashlib have HMAC? There we go. So you've got PBKDF2 based HMACs. Okay, there's a module HMAC. So there's separate to the module hashlib, there's a separate Python library called HMAC. So I lied, it's not part of the same library, but you get them both with Python. And Python has support for creating HMACs based on a key and a message for you. So you don't need to know this, but this the way in which HMAC actually uses hash algorithms is resistant to hash padding attacks. Fun little fact. That's basically the spoiler for the end of the evening. If you're a developer, don't use SHA-1 with a simple concatenation like this, use HMAC. It does it for you in a safe way. So does this make sense, everyone, that we're going to be focusing on how this particular crypto attack works? Because this little blurb here fits our situation to a T, based on how the attack works, blah blah blah, based on the hash of the message 1 and the length of message and the length of the secret and blah blah blah. You can calculate this for an attack and control message 2. It can be done on hashes with constructions similar to this, which is the construction that we've actually implemented, and it can be done against SHA-1. Like, that fits perfectly for what we're looking at tonight. Oh yeah, very cool, Jardeth. Quarter of Canberra's got NBN, hey? You're going to make me jealous, so you know. Jerk. Firmly a jerk. Sick Photoshop skills. No, Singularity, they're different. By the way, Singularity, why aren't you replying to my emails? I've got some stuff you might be interested in. Just reply to my emails. Hisakun, no, it's a challenge that I crafted myself to demonstrate the theory behind the thing. Tonight we're doing more of like a deep dive on a technique, and we build the challenge from scratch, and now we're going to solve the challenge based on the theory of the attack. We're not doing a pre-canned pwnable. I'm trying to dive right into the mechanics of how hash padding works. By the way, hash padding is in almost all the CTF. Like, it's a crypto attack that everyone knows how to implement and knows that everyone knows how to solve, so you see it in a lot of CTFs. Yep, Nens, that would also work, but that is dirty. You're right. And it's still vulnerable to the phenomena of hash padding. It just may have been unexploitable in this case. HMAC is the solution. Don't go and do your own concatenation of secrets with messages using a hash algorithm. Use HMAC, it does it for free and securely. Jardeth, good question. I'm not sure. That definitely goes beyond the reach of my hashing and crypto knowledge. I think is SHA-1 deprecated yet? Or is it coming up for deprecation? I mean, if you're building stuff now, there's really kind of... Okay, it's deprecated for certificates. Qualis is probably going to talk about certificates. Everyone's talking about certificates. But I reckon SHA-1's probably deprecated or coming up for deprecation just as a cryptographic primitive. If you're building software and you've got the choice between SHA-1 or a more mature hash algorithm, pick the more mature one now, before SHA-1 ends up broken. So Jardeth, is HMAC SHA-1 still fine? Maybe. I'm not too sure. I'm not the person to ask about crypto stuff. But if you're building new VPN things, I'd recommend against SHA-1 anywhere, because it's coming up for going the way of the dinosaur, I reckon. Null, that won't work because the signature won't match. The attack is more in depth than simply doing your own concatenation. I'll give a quick demo. Let's go and just use exploit. So if we run exploit, we get you're not administrator. If we go and in this send line of the token and go append the string admin and then run the exploit, we get bad signature. You can't just go and append admin and use the same old signature. You do need to do some crypto trickery to actually pull off this type of attack. This scenario is vulnerable to this type of attack, but it's a lot more complicated than simply appending the string admin. So no, it's not just appending. Null, where's your emails? I got nothing. They were offers for... who was I making fun of? Was it Singularity or Menstrual? Yeah, no, they're exclusive to Singularity, those offers. Yeah, gotcha, Jardeth. I'm not too sure about what's where SHA-1 is safe to use or not. I just know that in general SHA-1's dying. Yeah, gotcha. Good point, old mate. So yeah, I reckon don't panic if you've got SHA-1 being used in HMAC. If you've got SHA-1 being used elsewhere, don't panic either, but start to make plans to move away. If you're building new stuff, whether you're doing HMACs or not, I'd just recommend against SHA-1 anyway. Unless there's an overwhelming reason why SHA-1 would be preferable to something like SHA-2 or SHA-3 in your brand new implementation of software, pick the stronger one. If there's a reason to, then pick SHA-1, but I would just say if you can avoid it, don't use it. But you're right, old mate. Yeah, because it's being double wrapped inside by the HMAC process, then it would require, you're right, more brokenness for it to actually be a problem. Because attacks on hash algorithms are tricky. Like there's pre-image attacks and chosen something attacks and chosen that something else attacks, and to break it inside HMAC, you probably need a very critical break in the algorithm. SHA-1 is deprecated, yeah, cool. Yeah, nah, not that easy, Null. Not that easy. Alright, we should probably get on with it, hey? How does a length extension attack work? I might do my best at explaining it myself, and then we can go to Wiki when I fail to explain it, hey? Oh, I can already tell I'm going to fail. So this bit is easy when we craft the guest token. This bit that's hard. To do some thinking about hash extension attacks. So I'm going to create a big here doc and put stuff here. So how do hash algorithms actually work? So for example, SHA-1 of doot. How does it work? You know, people think that it's just a black box and you kind of go to the SHA-1 machine, hey, here's the string doot. Can you kind of, I'm going to put it in the chute at the top and then like turn the crank, and at the bottom is going to pop this really long hex string that might look something like that. And it's a black box, and people don't stop to think how the internals of that box actually work, which is understandable because you start reading crypto implementation white papers and crypto implementation RFCs and stuff, and your eyes go completely crossed. It's not unrealistic that people don't care much for how crypto algorithms work on the inside. But stuff like SHA-1, it actually works interestingly. How about the SHA-1 of doot 1,024 times over? I made a mess of that, didn't I? How does that work? How does it differ from the first one? Because people might think, oh, it's just like a bigger thing that you put in the chute at the top, then you turn the crank and the same size thing pops out the bottom. It doesn't really change how it works internally. Well, actually, when you're hashing a big message, it actually works a little bit differently to hashing a small message. So this is kind of how I understand the internals of, and this, by the way, the next like 10 minutes while I try to explain this is not canon. It is not correct. Don't trust it. Go and read the wiki article and go, oh, that's the thing that Justin did that was wrong. My understanding of how hash algorithms like SHA-1 work is that they chunk the message. Well, first of all, it starts from an initial state. I don't know what it is, but it's something. It's the state of the machine. So the machine that's kind of sitting there on the shelf that's ready to do some hashing for you, the SHA-1 machine, has all its kind of internal cogs and levers and all its internal machinery in a set initial state. I don't know what it is, but it's the same each time. So you put your input on the chute, the input chute for this machine, you start turning the crank. While you're turning the crank, what it's doing is it's actually taking in a single chunk of your message at a time. So your message gets chunked into bits of length n. I don't know what the number n is. I'm going to have to look it up in a minute. So your message gets chunked into bits is a bad word, chunks of length n bytes. And for each chunk, do mutate machine state, right? So the machine's sitting there, you're kind of turning the crank, and it's chopping up your input into fixed length chunks of a particular size, and it's acting on each chunk one at a time. And for each chunk, as it kind of falls through the inside of the machine, it's kind of like those Japanese pachinko machines, right? Pachinko. These things, right, with like the ball bearings that fall down and they bounce between all the little, you can see here all the little knobbly bits that the ball bearings bounce off, right? And each time it kind of bounces off all the cogs inside and all the wheels inside and whatnot, it's mutating the state. It's kind of going, this wheel turns a bit that way, that wheel turns a bit that way, because this particular chunk kind of trickled down through the machine and changed the state. And it's a deterministic process, right? Unlike pachinko, which is just total random bullshit. Every time a given chunk goes through, like let's say you're hashing doot times 1024 versus doot times 1024 plus fizzbuzz, right? Every time you do the first chunk, of these two messages, it's going to be doot 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 up until the length n, right? It's going to be n bytes worth of doot. And that first chunk for these two hash invocations is going to mutate the machine in the exact same way, right? So each time that doot 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 doot, you know, n bytes worth of doot goes through the machine, that chunk will mutate the machine into a given state. And that's deterministic, so it'll be the same. So the machine starts off in an initial state, and then each chunk will mutate the machine's state until we get down to the end of the message, right? By the time you've chunked this into lengths of a given static size, where each chunk is of a particular length n, each chunk then mutates the machine. The state of the machine after the last chunk has had its turn at mutating the machine's state. That machine's state is the hash. You know, you finish turning the crank, the message has been chopped up, it's been fed through. The last one goes through the machine, mutates the state, the machine goes, there's nothing left in the hopper, there's no chunks left to go. So I'm going to take my internal state, poop it out onto a little receipt, and I'm going to drop that into the outbox. And that's the output of the hash machine for that message. That's how I believe it's the Merkel Damgard. I'm so pronouncing that wrong. That's how that type of hash algorithm works, right? Except there's one bit that might be a bit tricky. If this is the last chunk, and the chunk is and len chunk is less than n, pad the chunk. If you get to the very end of these doots and the very last chunk is not a full chunk's worth of doot, then you need to do some special padding, right? So that it becomes a full entire chunk of the full chunk size. Because if you were just to feed half that last chunk, if the last chunk coming in through the hopper wasn't a fully chunk width chunk, then when it mutates the machine might get jammed because it can only deal with things of a full chunk length. So the last chunk to go through the machine, if needed, will be padded. And there's a special algorithm. It's not simply, padding it with nulls, there's a special algorithm that decides how to pad it based on the length of that last chunk. Still, that's how SHA-1 works. SHA-1 has a prescribed initial state. I don't think it's all null. I think it actually has a prescribed initial state. We'll go and check it out and see what we can find. SHA-1 has a particular way of padding chunks. SHA-1 has a particular chunk length that it mutates with, and SHA-1 has a special machine state mutating algorithm that, based on the chunk, we'll probably feed chunk to the mutate machine state function here. SHA-1 has a particular machine mutation algorithm based on a given chunk. It will mutate itself in a certain way. But that's all that a hash specification is, basically. It's what's the value of n, how big is each chunk, what is the padding algorithm for the last chunk if it's not big enough, and how does each chunk actually mutate the machine's state, and what is the initial state. That's how hash algorithms are basically built. So what's kind of interesting is if this is how hash machines work, and if the output of a hash algorithm is just the final state that the machine is in, could we just go and get our own SHA-1 machine, change the state to be an existing SHA-1 hash, and then feed in one more chunk, turn the crank, mutate it once more, and be able to calculate the value of any message, even if we don't know what the message was, appended to that our own choice of message? Can we calculate the hash of that based on our understanding of how hash machines work? That's exactly what a length extension attack is. Based on the fact that hash algorithms operate on this machine state idea, and every time you pass a chunk through and turn the crank, it just fiddles with the inside mechanics of the machine and sets it to a brand new state, and the output of a hash algorithm is simply the final state that the machine's in. Yeah, we can totally get our own hash machine, change the internal state to match whatever the hash from some of the jerk's machine was, and then feed in another chunk, turn the crank, and get a brand new hash with an appending of message 2 on the end. We can do it. That's how length extension attacks work. Implementing it sucks, and that's what we get to deal with after the break. I'm going to take a quick 5-minute break. That's what we have to look forward to. But hopefully that makes sense. If it doesn't make sense, I'm going to paste this link to the length extension attack into chat. Feel free to read it. I would suggest just reading the top bit here. I'd suggest not reading the example unless you want to see the spoilers, but we're going to be working through this. I'm not going to read down below the fold on this page. I'm going to see if we can, based on our own understanding of hash algorithms, actually implement this from scratch. Like, if that's not exciting, I don't know what is. So I'm going to take a quick 5-minute break. If you need to grab yourself a bevy, if you need to grab a glass of water, whatever you need to do, go do that now. Now is the time. Now is also the time, if you didn't quite understand the explanation of how this attack is going to work, now is the time to maybe go and brush up on the wiki page and see if you can get a handle on where we're going. And after the break, we're going to give it a go. So I'll see you on the other side of this.
Like a Hellcat.
I'm running away from this pain. I'm trying to find a new way where the sun's shining down on my face. I'm running away. You're in a toxic relationship. Time to be free. You're not good for me. Please play me, I'm running away from this pain. I'm trying to find a new way where the sun's shining down on my face. I'm running away. You're in a toxic relationship. Time to be free.
Alrighty, no rest for the wicked, or not that much at least. Let's get back to work, eh? Length extension attacks. So I've never actually done a length extension attack. Now that hopefully we understand the theory behind a hash padding attack or a length extension attack, and that is to initialize a hash machine with the same internal state as given by a signature here, for example, and then basically feed in a little bit of extra data and turn the crank once more. Hopefully we'll be able to do that with Python. I'm hoping hashlib will let us instantiate a SHA-1 hasher, set the state to be this here, for example, and then go ahead and do a couple of needfuls, followed by appending the string admin, turning the crank once more, and getting the output. That's the theory. Let's see if we can actually pull it off. So this is going to involve me reading the hashlib doco so that I can actually understand roughly. I've got way too much garbage open here. Let's go and close some stuff. Oops, didn't want to close that. We need hashlib. We don't need that. We don't need this. We don't need that. We don't need URL lib, we don't need time, don't need that, don't need crikey. Alright, cool, so here's the hashlib stuff. I'm going to have a quick browse through the hashlib doco, see if anything jumps out at me as looking useful. If we get desperate, there are tools that will basically do this for you, that you can download off GitHub and run, and it will basically solve the whole thing for you. I'm curious to see if we can actually do this ourselves, famous last words. So let's see. This is useful. We can actually use Python to cough up the block size for us. Okay, so I'm just curious. I'm going to start playing around with some stuff. Let's edit hashes.py. Let's go Python 2 just to maintain compatibility with our Pwn tools exploit. Let's go and pull in hashlib. All right, let's do this here. Except we're going to do it for a SHA-1 based machine. Alright, so let's go message equals doot times 1024. Let's make it a nice odd number, 1000. So what we should be able to do, let's just go ahead and print that SHA-1 of m.hexdigest. Alright, so that's the SHA-1 sum of doot times 1000. Now let's see if we can kind of break this down and do it manually, block at a time, using the update function. So now what we should do, so a hash object has a block size. I'm just curious, if we go ahead and do print h dot, is it block underscore size? Yep. Block size. What is the block size of SHA-1? Okay, so the block size is 64. So remember back here when we said the message gets chunked into chunks of length n? For SHA-1, it's 64 bytes. Good to know. Just go and comment that out, because I'll use that in a second. Oops. So we're going to use hash.update with the object arg, which must be interpretable as a buffer of bytes. So I'm just curious, if we do for the list of m from I through I plus j for no, it's going to be h dot block size for I in range 0 len doot h dot block size. So what this should do is give us a list. So this here will give us a list of M, which is our 1000 doots, chunked into chunks of length block size. So it's going to go from, so I is going to start off as being 0. It's going to go up to the length of doot, and it's going to increase by h dot block size each time it ticks over in this range function. And we're going to use each I that this range returns to go from 0 up to 0 plus block size, followed by 1 times block size through to 1 times block size plus block size, and this should chunk the message for us. Print M. So if we just run hashes, it's not happy with this. We've got to do for chunk in print chunk. It's not doot, it's M. There we go. So what we can see here is this loop. This here is chunking doot into chunks of length block size. So this is giving us each individual block that is mutating the SHA-1 machine at each stage of a normal hash operation. So now we're going to do for each chunk we're going to do h dot update against the chunk. At the very end we're going to go print h dot hex digest. And we should get this matching that. I don't know if this is going to actually help us, but yeah, we do get that. Now I'm just kind of curious. I'm just going to quickly divide that by 2. I want to check something real quick. That still matches, okay. So update, h.update doesn't actually do a full chunk. It does a full chunk at a time, and if we don't fit in a full chunk, it'll wait till it gets more chunks before it actually does an update. That's fine. We can work with this. But we still haven't kind of come across how padding works. Do we get finer grained access to hash.update, or do we just get hash.update? Yeah, we don't get finer grained access, we just get that update function. That's right, let's have a look at how SHA-1 padding works. Because this here is a rough approximation of how hashing actually works, except this h.update isn't as strict as I would like. I would love for it to insist on taking exactly one chunk at a time. But even if it's not, this is still a good approximation for how it works. So this is how the SHA-1 padding algorithm works. But now I'm starting to question whether this bit here is correct, or does the padding always happen even if the last chunk is exactly the right length? I guess we'll find out. Let's go if len chunk is less than the block size, print I need to do padding. And we should, if we run this, get the message I need to do padding. Yeah, because the last chunk isn't exactly a multiple of the block size. It's not exactly equal to the block size, I should say. That the type message is not a multiple of SHA-1's block size. So let's see if we can do this padding ourselves and see if we still get the exact same hash. If we don't, then it proves the fact that padding always happens, and we're going to end up with double padding due to this update. Let's give it a go. Let's try and implement padding ourselves. So we need to append a 1 bit, then we need to append a number of 0 bits until the message length equals 448 mod 512. Until the message length mod 512 equals 448. Is this SHA-1? Yeah, it is SHA-1. 512 bits. Remind me, what did we say the block size was? 64. 64 times 8 is 512, yeah? 64 times 8. Yeah, 512. So it's 512 bits, which is 64 bytes. Okay, cool. So I need to do padding. Let's go. How are we going to do this padding? Can you have a binary string in Python? How are we going to actually implement this in Python? What's the easiest, what's the best way? How do we just go binary to ASCII? Is this it here? Nope. That's A to B, we want B to A. Nope. It's not what we want. This is what we need here. Do we just want to steal this? Append a 1 bit, append 0 to 511, 0 bits until the message length is 448 when mod 512, append the length of the message to the 64 bit. Big endian integer. That bit there's easy. We can use struct, or we can just even do pwn tools pack to do that. Chat's got any good ideas on how to do this? Don't need Craggy, wow. I mean the Python, it probably wasn't the Python 3 hole, it usually shouldn't make too much of a difference. Look at the update function and the unprocessed section. Interesting, thanks Wolf. This might be useful. The update function. Yeah, gotcha. It looks like this is leaving the member variable unprocessed as being the remainder of the kind of the last chunk. It leaves it in the canon until such time as you need to actually produce the digest. Gotcha. Oh, okay, check line 130 does the padding. All good, old mate. I'm trying to actually implement the SHA-1 padding algorithm myself, which, if you're interested, looks like this. You append a 1 bit, then you append enough 0 bits until such time as you've got enough space left to do number 3, which is to append the length of the message as a 64-bit big endian integer. I'm just thinking about how to do bit juggling in Python, really. @Wolf is saying to check line 130. Yeah, see, I don't really want to do that because I thought of just adding hex 80, which is the bit 1 followed by a whole bunch of zeros, but we may... I guess that'll be fine because you never ever end up with like half a character unless you're hashing binary data and there's not a full byte there. Can you even have that in binary data? Not a full byte? Probably not. We should be able to just do, yeah, hex 80. It's nasty, but it doesn't exactly, because this, I loved how succinct this was. Append a single 1 bit and then enough 0 bits to do this, and only then do that. But we should be able to just do hex 80, which will be a single 1 bit and then 7 0 bits, and then we'll just do this until such time as we've got message length until the chunk length is 448, and then we'll have 64 bits left for that. Yeah, that should be safe. Let's do that. Let's do it like that. So let's go chunk plus equals hex 80. While the length of chunk is not equal to 448, do chunk plus equals null byte, and then chunk plus equals, we should probably use struct. Python construct. Oops, I'm in the bad place of Vim. I'm in the really bad place of Vim. Visual. There we go. We need to append a 64-bit big endian integer. Big endian's greater than 64-bit int is long q. It's going to be unsigned. Yeah, it'll be unsigned because it's a length. 64-bit big endian unsigned long greater than q struct dot pack. Was it greater? Sorry, was it greater than q for big endian? I think it is. Yep, greater than q for big endian. It's got to be the length of the whole message. Fizzer. No worries at all, mate. You'd say the elegant solution is to use entire bytes. I think so too. I think I was making it more complicated than I had to. So now I've got to do the length of the message. Oh, so it's the whole message, not the padded message. So it's going to be the length of M. Right, so this here is a manual implementation of the SHA-1 padding, and let's see if when we run this script we get this hex digest equals that hex digest. That's just told me that SHA-1, when the last chunk is exactly a multiple, when the last chunk is exactly the block size, that is to say when the whole message is an exact multiple of the block size, padding doesn't get done. Because we're doing manual padding, I'm curious to see if the padding has padding done. If the hashes don't match, then either SHA-1 always pads, in which case there'll be an extra block of just padding, or I've screwed up the padding implementation. So either SHA-1 always pads, or I've screwed up the padding implementation. Which is it? We go and comment all this out, then the hashes match. Does SHA-1 always pad? Okay, yeah, that makes sense. So it looks like SHA-1 always pads, even if the message is an exact multiple of the chunk size. It's going to avoid collisions. That makes sense. Yep. Collision resistance, okay. Are we going to have to actually implement SHA-1 from scratch? Can we just not use hashlib to basically do half the job for us? I probably should switch back to the Python 2 doco for hashlib. Maybe there's like a private function we can access. Let's go and just print dir of h to see what functions are available to us on this hash object. Block size, copy, digest size, hex digest, name, update. The other thing we want to be able to do also is basically boot up to basically set the state of a hash machine. Maybe Python's not going to actually expose it to us via hashlib. Python SHA-1 set state. We may be able to just pinch this. It's under the stuff in the license file. What's the license of this? Great, that helped. Thank you. This is basically BSD, so we should be able to take this and do what we want with it. Yeah, Menstrual, I'm thinking, good idea. I'm thinking len chunk would be bytes, not bits. Oh, yeah, hang on. Do we need to do it in bytes or bits? Good idea. I'm not sure if we need to get the length of it in bytes or the length of it in bits. Good point, Jeff. Good point. I still don't think that's why we're failing though. I think it's because SHA-1 always pads. Means I think we're going to just pinch this code here and muck with it. Is there an updated version? No, 0.2 is the latest. I reckon we'll just go and use this instead of the hashlib stuff. So we'll just go and chuck it into hashes. Let's get rid of, we'll leave hashlib in there. I'm going to be awful and just paste it straight into the file. If we go and muck with this code, we may be able to basically get the ability to set the state as well as the ability to do fine-grained control over updates, and maybe we'll make the hex digest simply not do. Yeah, I think we're going to monkey with this code here to basically get tight control over the updates. Just going to quickly do h2 equals SHA-1, print SHA-1, print h2 dot hex digest. If we run that, what happens? Or is it just, no, it's no underscore. So I'm just curious, if we instantiate a fresh copy of this class here and then straight away do a hex digest, what do we get? We get this here, which doesn't match the state. So it looks like at least one iteration got done. Gotcha. We don't need this dir anymore. Okay, so we need to dive in and see if we can understand how this digest function works. You know what? This is straying off into crypto territory that I would love to get done, but I spent way too long waffling tonight to feel like modifying the SHA-1 code. We might leave this for another stream, or I might just give it a go in my own time and then report back with what I found. Would anyone be disappointed, having explained exactly how hash padding attacks work, if we go and do what you would do during a CTF anyway, which is to go and just use an off-the-shelf solver? I think that's what we're going to do. Where's exploit? I think rather than I think we're just going to use a tool to do these two stages. Well, we'll do this ourselves. No, we'll use a tool to do these two stages. Okay. Otherwise, we're going to be deep in crypto, and it's going to get to midnight, and I need a good night's sleep because tomorrow's going to be a big day. So let's do that. Hey, let's just go and use some off-the-shelf tool. I'm sorry to be taking the easy way out, but screw it. I feel like going to bed, so I'm going to take the easy way out. Maybe another night we'll actually dive into the SHA-1 code. I'm just looking at this going, I can tell this is going to be a long and painful night if we try to modify this to basically do a hash padding attack from first principles, to actually be able to understand how padding works, to be able to set the state, and to be able to basically take a hash, feed it into this to set the state, to then mutate one more stage, doing the padding manually and understanding some compensating steps we need to do to be able to achieve the attack. It's doable. It's just going to take us till midnight. I don't want to spend till midnight modifying crypto code. I'm sure you don't want to spend till midnight watching me modify crypto code. Noel's going to cry himself. Okay, I'm sorry about that, but it's the way we're going to be tonight. Okay, cool, that Wolf. I will bookmark that, and I'll check these out in my own time sometime. I promise. Maybe I've got a lot to do. Maybe I will. Maybe I won't. But it would be a good thing to actually implement this ourselves one night. Maybe we'll just leave it on the back burner, and we'll actually revisit this challenge and do our own solution by modifying an existing hash library. For the time being, we're going to do what you would do during a CTF anyway, which is to Google for hash padding attack GitHub. And click the first thing you find that says it's going to do hash extending for you. And it's written in C, okay? This is going to get interesting. That's what I'm worried about. That's what we're going to end up tonight if we try it ourselves. And it took a couple of weeks for Skull Security to do it, so we're going to clone this. We're going to build it and see how it looks. Is there build instructions? Nope, but we get a make file, so hopefully the make file will just work. cd hash extender make. That was easy. There we go. We've got a tool off the shelf that says it's going to do it for us, and here's the help file. The usage is hash extender dash dash data equals the data, dash dash signature equals, I'm guessing, the original signature, dash dash format equals, you give it a format, then you give it some options. So let's just go ahead and leave these to-dos. Let's comment out this guest nonsense. And let's comment out this as well. And let's just go t.interactive. Okay, so here we are. So we've got an example token and an example signature, and now we need to provide our own token. Oh, this is going to suck. So we've got to paste null bytes. How are we going to do this? Okay, let's just go ahead and get a copy of this and use it as a demo. Paste that there. Let's go back to that hash extender. Run hash extender. So we need to do -d. The data is going to be the original token, right? -s is going to be the original signature. Let's see right here. So I'll copy the signature. -a, the data to append. Well, let's just go. The data to append is admin. Because all we want to do is make sure that the role has the string admin somewhere in it. So this data we're going to append is admin. -f for the hash format. I'm going to guess we just do SHA-1. Is there an example? What am I saying? -f. Valid types. SHA-1. Yep. There we go. -l. The length of the secret. Now we're kind of cheating here. If we go back to the challenge, we can see that the secret is a SHA-1 hash, which is 40 characters long. So we're going to go, the length of the secret is 40, right? So if we run hash extender with these options here, it does the hard work for us. Here is the new string, and here is the new signature, right? Now this string has been hex encoded as ASCII. So now if we do, I'm going to do Python, oops, new line fail. We do .decode hex. There we go. So we can see that this is what the new message looks like. It's got the old token, expiration equals blah, and role equals guest, and then it's got a whole bunch of basically what the padding used to be, right? We saw this hex 80 from what we were trying to do before. We've got a whole bunch of nulls up until the 64-bit length of the message, which is hex 02 at, which is going to be OX 200 and something. And then our string we're going to append admin. And we also got the new signature out of the hash extender. And the hash extender used the principles of the length extension attack to basically construct this here and give us the hash based on the message 2 of a whole bunch of the message 2 being hex 80, then a whole bunch of nulls, then OX 200 and something, and then admin. And that was a lot easier than actually doing the attack ourselves, right? It would have been cool to do the attack, but I got a boost bar in the fridge and I'm hungry and I want to go to bed and watch Netflix. So we're just going to use the off-the-shelf tool. The question is, how are we going to feed this with all these null bytes into exploit.py, right? Because if we run exploit, oops, let's go quit that. We don't need that anymore. Twitch, hash padding, run the exploit. Right, we need to provide the token, but the token has to have all these null bytes in it, which we can't exactly paste in. Right, so what we're going to do, what we're going to have to do is our exploit is going to have to ask the user, ask for a malicious token, or ask for a crafted token, and ask for a crafted signature. Now the signature, we can do raw input, enter crafted signature, and for the crafted token we can do token equals the raw input into the crafted token, but we need to do a .decode hex on whatever got entered by the user to basically simulate exactly what I did here with this string. .decode hex will actually give the bytes that pertain to this hex encoded string, because we're going to be able to just paste in this here, right? And then our exploit will actually go and read all these and translate them into the nulls for us before storing the result in the variable token. Now, I'm probably reusing variables here like a terrible person, aren't I? Yeah, token and signature were the originals. So I'm going to call this crafted token and crafted signature. So we're going to be asking the user for those two. And then we're going to send them. And we'll do this again. Let's go yank 5 down. Alright, except this time we're going to be sending the crafted token and the crafted signature. We don't need to do t.interactive anymore because we don't need the user to interact. We're just going to print till end of file. Right, so now we should be able to run the exploit again. And Pwn Tools this time will actually ask us for a crafted token. So if we were to give it this here, .encode hex, and give it this hex encoded token. Oop, shit blew up. Hex decode was unhappy with that. Is it because there's a new line? It's probably because raw input. Does raw input include the new line? ASDF. No, it doesn't. Why is hex decode blowing up when I give it a crafted token of that? Odd length string. Did I like fail at pasting something maybe? Let's try again. Here's the token. Dot encode hex. Grab that. Paste. Enter. Blew up again. Why is it getting a odd length string? Shouldn't be an odd length string. Crafted token equals raw input into crafted token. Dot decode hex. For one. Where's this odd length string coming from? I'm going crazy. Where's this coming from? Alright, Python's doing something weird. What's Python doing to me? Let's go and get rid of this. There's a suspicious looking blank there. I think I've got a new line being read in. Why is there a new line ending up in this raw input? Is the terminal doing it maybe? And then inside the REPL you get different behavior with raw input. Python raw input trailing new line. Does it sometimes get included? There shouldn't be a trailing new line there. What's going on? Let's go and encode this as hex. Where is that trailing new line coming from? Raw input should not be putting a trailing new line there. I am definitely going crazy. Pwn Tools user input. Does Pwn Tools give me something that's going to more sanely get user input? No, Pwn Tools doesn't give me anything for user input, probably because raw input's supposed to do the job, but for some reason raw input is keeping a trailing new line. Is it worth just doing this? I don't know why Python's giving me a trailing new line with raw input, but I'm just gonna go and remove it myself. That's really peculiar. If I wasn't totally keen to go offline and watch Netflix, I would look into why this raw input is keeping a trailing new line. But I'm just going to go and chop it off. This is buggy and hacky, and don't do this. What about crafted signature? Print crafted signature dot encode hex. Does this have a trailing new line? I'm guessing it probably does. It does. Where are these? Why is Python keeping trailing new lines there? Let's go and just chop that off using this same syntax. Weird. All right, I think we're back on track now. Let's try again. Let's run the exploit. So here's the token. So here's a guest token. Let's just, for example, oops, I'll probably want to add some more helpful stuff here. Hex encoded. So we need to give the crafted token hex encoded. So I was asking for a hex encoded crafted token. Let's go and take the guest token and encode it as hex. Grab that. Whoop! I just pasted it somewhere I shouldn't have. Paste. Enter the crafted signature. Let's just go and paste the original signature. There we go. We're a lowly not administrator. Great. So now we've got an interface through which we can enter hex encoded bytes for the crafted token, which will let us have the null bytes that the crafted token will need to have. If we were doing the whole in Python hacking of the SHA-1 library, we wouldn't need this horrible hex encoded user input interface, but that's the price you pay when you're being lazy and using off-the-shelf tools. Can't recreate it. Did I turn off line buffering? I did turn off line buffering, but I turned that off in exploit here, and it should only be for the challenge process that I've got unbuffered output. I don't see why this here would be causing my raw input to have trailing new lines, because my raw input has nothing to do with that Pwnlib tube that I created up top. Yeah, I don't think that raw input should be doing that. Use strip, I probably, could have used strip. Probably should have used strip rather than just chopping off the last character. I should have used strip instead of chopping off the last character. Thanks, Atwolf. Oh, nice work, Volko. They probably could backdoor that. As well as that, keep in mind, Volko, that an encrypted /boot doesn't give you integrity. It only gives you confidentiality. Someone could go and replace your /boot with something that smells encrypted when you boot it up, and you get asked for your passphrase and you think it's decrypting boot, but really the boot partition is a totally backdoored kernel that's going to screw you once your machine's up and running. Encrypted /boot, I don't think gives system integrity. Netflix and crypto. Absolutely, at Wolf, you could do that. You could guess the length of the secret by trying over and over again with different candidate secret length values and do an online brute force, and you'd be online brute forcing the length of the secret, which is so much easier than doing an online brute force of the actual secret. So that's exactly what you would do at Wolf if you didn't know the length of the secret. Yes, irrelevant. How good is it, Volko? So good. Fanada, yeah, you have missed quite a bit. It wasn't anything good, but you missed quite a bit. We created a hash padding challenge, and then I explained how hash padding attacks work in principle, which I was pretty proud of that little description, by the way. I think I did pretty well at explaining how SHA-1 works without actually referring to how it works, and then I absolutely failed by trying to hack or interface with hashlib, Python's hashlib, in a way that would let me achieve what I wanted to achieve. Found out that if I wanted to actually manipulate the internal state of a SHA-1 machine, I would need to use a manual implementation of SHA-1. I wouldn't have to do it myself, I'd have to go and steal someone else's, but then I'd need to modify their crypto code, and that's when I started to go cross-eyed and decide to use an off-the-shelf tool to perform a hash padding attack, which we're about to give a go. We might do the hacking of SHA-1 another stream, but not tonight, Zerg. Yeah, it's strange. Bedtime. Alright, night, Jardeth. Catch you soon, eh? Yeah, weird, Volko. I'm a bit curious and a bit concerned at that, but hey, tonight's not the night for debugging Python's weirdness. I think we're almost done. So we're asking for a crafted token, which is hex decoded automagically. I'm doing this instead of .strip because I don't program like a grown-up, I program like a child and just do stuff till it works. We're going to send them back down the gullet of the challenge, and we're going to see if we've become an administrator without knowing the value of the secret. So let's run the exploit. So here is a token, just to kind of freshen things up. I'm going to run hash extender again, change the data to be the new value of the token, change the signature to be this value down here. We're going to append admin. It's a SHA-1 hash algorithm, and the length of the secret is known but guessed to be 40 characters, but we know it's 40. We're cheating tonight. And we get given a string. Here it is. So we're going to copy that, and we're going to paste that in to our exploit as the crafted token hex encoded. Boom. Enter the crafted signature. We're going to go and copy paste the signature that hash extender has given to us. Hit enter, and fingers crossed we are an administrator. There we go. You're an administrator. Hooray! So that's how a hash extension, a length extension attack or a hash padding attack works. Based on the fact that SHA-1 and friends use this continually rotating internal state machine followed by a final padding exercise, you can take any hash off the internet. For example, like you can go and get the hash of Debian, you can download a Debian ISO, download the hash of the Debian ISO, and based on this principle, you could go and append some extra data to the end of the Debian ISO and generate the new SHA-1 hash of that modified ISO without bothering to do the hash of the whole ISO up until when you modified it. I don't know why you'd want to do that, but you could do it if you wanted to. You could hash extend the SHA-1 sum of any SHA-1 sum that you find. It's up to you to think about where this might be useful. Really, it wouldn't be useful in the Debian case because you could just do SHA-1 sum of the modified Debian ISO and there's your modified hash. But in the case that there's some secret data being mingled into the hash or prepended to the message being hashed, where it looks anything like this, this here, you can do length extension attacks. To defend against them, you should use the HMAC way of thinking of using your hash algorithm. It double wraps it and does some other stuff to mitigate against hash extension attacks. Hopefully that makes sense. I apologize for not doing what we really wanted to do tonight, which was to implement this ourselves. But the good news is, if you come across this in a CTF, and you will come across this in a CTF, it is a super common crypto problem to be given an API to something and be given a token that has been hashed with a secret, and you don't know what the secret is, and you've got to go and give a message and a signature, and the message has to have the word admin in it somewhere. Very common CTF problem. And the good news is Hash Extender on GitHub looks to be the goods. I have used this before in CTFs. You got to compile it. It's a C-based program, but it's a super clean compilation. You just do make, and it builds it, and it will perform hash extension attacks for you. Before I go and enjoy my chocolate and my Netflix and my snooze before the big celebrations tomorrow, any questions, queries, concerns about anything that's been covered tonight? I would hate to let people go to bed wondering, and I would love the opportunity to say that is a really good question. I don't know. So if you've got them, ask them. Or if you want to just see how long you can keep me sidetracked for, then let's do that. Sharman and Friends, the new Hashing Kids show. Yes, that exactly. Shows the importance of strong secrets. If an algorithm was leaked somehow. Yes, excellent point, Menstrual. Is it Kirchhoff's principle? Nope. Yes. A crypto system should be secure even if everything about the system except the key is public knowledge. What this is to say is that if you're ever tempted to roll your own crypto, the first step is don't. The second step is no, really don't. The third step is, if for some reason you absolutely must implement your own crypto system, don't. But if you must, then this principle is important. The mechanics of how a crypto system works should be considered to be known to your adversary. You can't go, oh, I'm going to hash it 3 times and they're not going to know to do it 3 times. That is a really shitty way of using crypto to achieve a goal. You must assume that everything about the system, including the way in which you use algorithms, the way in which you use mathematics, everything about the mechanics of the system should be considered to be known to your adversary. Only the key should be considered to be secret. Your security should not hinge upon the obtuseness of your methods or the crazy way in which you do crazy math stuff. The way in which you use math should not be the security linchpin. The key should be what you rely upon. Which brings us onto a second point. Yeah, you're right, Menstrual. If the algorithm was leaked, then you need to consider offline brute force of the secret. For example, in this case here, if we go and look at this, if you know that the method by which the signature is created is that a static secret is prepended to this string here, and then this is just a SHA-1 hash, then yeah, if you've gone and given these 2 values away to an adversary, then your adversary may sit there burning CPU time trying to guess what that secret could have been. And as soon as they guess the secret, they can create their own tokens and secrets, signatures, without using a hash padding attack. For example, if you're actually doing HMAC and not doing this ghetto concatenate stuff together then SHA-1 it trick, then even if you're using HMAC, then an offline exhaustive brute force of your secret token that succeeds would jeopardize the whole system, because people could then create their own HMACs based on the deduced secret value. So you're right, Menstrual. Keep your secrets secret. Keep your secrets long, of high, good quality entropy. Make sure that they can't be guessed. If, for example, we found out that when you install a Ruby on Rails application and the cookie signing secret is randomly generated, if there was a weakness in the way in which that cookie signing secret was being generated on everyone's machine, and we found out that it was one of 32,000 or whatever it was. How many possible Debian keys were there? Back in the days that Debian broke OpenSSL. then if we found out there was a weakness in the way that something, let's say Ruby on Rails, was generating those secret values, then it may greatly reduce the offline complexity of the complexity of the offline brute force against someone's, brute forcing someone's application secret. Yeah, 32,000 possible keys. Hang on. 98,000? Broken version. Maybe it was 98,000 bad keys. Yeah, whatever it was way too small. Good point, Minstrel. Rant over. Rant about strong secrets over. Arthur J. Thorpe, I'm glad you enjoyed it. Thanks very much. Why don't I drink 4X? Because I've still got taste buds. Cooper's, while not a fantastic craft beer quality beer, it still tastes good. 4X's, to be honest, 4X's pale ale I have been known to drink on occasion, especially when I'm driving, because it's a MIDI. It's a mid-strength, and it's not too bad. Like, it's not good, but for a mid-strength beer, it's okay. It is refreshing for the Queensland summers, and it's only 3.5%, a standard per stubby. So I have been known to drink the 4X pale ales, but I wouldn't drink anything else that has 4X written on it. Even though I'm a Queenslander, still wouldn't. And don't make me start asking the Victorians if they drink Victorian bitter, or why they don't drink Victorian bitter. Exactly, Atwolf. Exactly. Thought PIDs went higher than 32k. What is PID max? Does it differ on 3264 bit? The default PID max is 32k. I guess you can probably change it if you really wanted to, but of course I think we're probably interested in the default. What is it in my Docker container? 32k. There we go. Looks like it is 32k. Volko, why are you worried about the confidentiality of /boot? What on /boot? I'm genuinely curious. I'm not trying to call you out. What on /boot would you be cared about the confidentiality of? Would you care that they know which kernel version and grub menu items you have? To me, that doesn't seem like the sort of details that I consider sensitive. Fair, like encrypting all the things, fair enough. Keeping as much private and confidential as possible, fair enough. I just didn't see /boot as worth the trouble confidentiality wise. I very much care about the integrity of /boot, and I would love to implement a solution to ensure its integrity. Confidentiality I'm not so worried about. VB soon for me. Yeah, very cool. Very cool, Atwolf. I have seen challengers use the Debian keys before. It's a fun one to exploit. It's been painful in my experience doing an online attack, trying to find out which of the bad key set was used by a particular person. That's cool though, doing it based on the art, because that makes it an offline attack as well. I've had to do online attacks with Debian bad keys, but the offline attack based on the art, that's a cool idea. Oh, right. So Volko, you're probably more worried about breaking boot off so that it's in its own little thing and the rest of / can afford to be encrypted because /boot's no longer on it. That makes more sense. Yeah, but then you realise that you can have your cake and eat it, so why not encrypt it? Yeah, very cool. So grub's still in plain text in the master boot record and whatnot, but the rest of boot is encrypted. That's cool. I mean, if it's easy to do, yeah, why not? Why not ensure the confidentiality of your boot? But yeah, putting /boot on / therefore making slash not able to be encrypted without this one weird grub trick. That's painful. You kind of do want your slash encrypted. I mean, the most important thing to encrypt on Linux is slash home, but who knows what is in your syslog and other things that may hurt you if they fell into the wrong hands. Okay. Right, Volko, did you encrypt slash in place, did you? I didn't know you could encrypt slash. I didn't know you could encrypt in place. I haven't had to do it because I've always encrypted from the get-go. Volko, all I'd suggest is if you've gone and encrypted in place, or really if it's a disk that you've only just kind of finally gotten your encryption all set up with, would be to make sure that you scrub the free space on your drive. You can do that if the whole disk is encrypted. You can do that. Backup and restore. Yeah, cool. For anyone else who's running full disk crypto on Linux, if you didn't do the secure wipe during install, it might be a good time to do it after install, just to make sure there's no data left behind on the corners of unused corners of your disk. You can just go sudo dd if equals dev 0 of equals /0, so it'll just create a file called 0 in the slash of your file system. bs equals nice big number 1 megabyte. Do that. And let that sit there, and it'll fill your disk. There you go, I've already got 2.2 gigs, and then once that's done, you can sudo rm/0. We'll get rid of that 0 file, and then if you're running an SSD, make sure you do a trim, otherwise you'll have horrible write speeds and probably start killing your disk if you leave it kind of full for too long. Trim on Lux is something that you may want to look into also, whether it's appropriate for your circumstances. I mean, if you're running an SSD, file recovery is generally pretty hard anyway, if trim is working. If you fill your slash, you might have system instability in between the time that you do this and rm the /0 file, so do it at your own peril. I have done it before. I wouldn't do it on a production server, but I've done it on desktops when I wanted to do a quick secure wipe of all the unused space on my disk. As with everything, your mileage may vary. That's my hot, terrible tip for the night. Yeah, Volko, the other thing is dev random. I don't know if dev randoms, you scrub the drive half to backup. Yeah, good idea. The reason I choose /0 is because it means that all the data that does get written to the disk looks like Lux noise. It looks like, I mean, I don't know if there's a difference between Lux noise and dev random. There shouldn't be. Lux noise should look like random, and dev random should look like random noise. But still, I like the idea of letting the full disk crypto basically govern the random noise to make sure it actually, blends in with the rest of the disk. Probably unnecessary, but that's how I've done it before. That's a good idea, Wolf. Aliasing DD to show status equals progress. Yeah, good idea. Might be a good idea to also alias DD to ask the question, are you sure, before it lets you do it. Maybe kind of put in a mandatory wait to say, go take a walk, think about this, and in 1 minute come back and then hit yes. Because, as we all know, DD stands for Disk Destroyer. Alright, that's enough off topic for me tonight. Thanks very much, FastChar. Thanks everyone who stuck around. Hope you enjoyed it. Hope you got something out of it. Even though we didn't get into the nitty-gritty hardcore demo, we at least did the softcore demo. And hopefully you followed along. Hopefully my explanation of how hash algorithms work and how a hash padding attack can be performed and the principles of it helps you, be it in a CTF or be it in finding and exploiting bugs in whatever it is that you like to do. Volko, be careful about that. It depends on the dash user 1 for DD depends on the system. I have killed a DD that was in progress because the DD I was using didn't support the user 1 trick. I think it might be the difference between Linux and BSD. Maybe it was a BSD box that I tried to send the user one signal to, and it actually killed DD, which was not really what I wanted. What's a boost bar? It's a chocolate. No, I'm not sure if you're trolling, but it's one of these guys. If anyone hates it, blame Menstrual indeed. Cool. Thanks very much, everyone. I will... What am I up to this weekend, this Sunday? I think I'm free Sunday. I wasn't free the Sunday, just gone, had a birthday crop up last minute-ish. But if I manage to keep the schedule free, then I will catch you all Sunday evening. Stay safe. Enjoy your festivities tomorrow if you're celebrating Australia Day. And, I don't know, take it easy.